Hi and Assalamualaikum warahmatullahi wabarakatuh. I am Nur Nabiha Akila binti Zulkarnain from University Malaysia Terengganu. I am representing my group to present about our project, the role of graphene oxide addition on microstructural properties of yttrium barium copper oxide superconductor. Next, I will briefly explain to you about what is superconductor. Superconductor is a material when it's cooled below its critical temperature, it will become superconducting material and has the ability to conduct electricity without any resistance. The existence of copper pair carries supercurrent without energy loss. In superconducting state, superconductor shows a perfect dimagnetism or a perfect screening because of the total flux density inside the superconductor is zero. This phenomenon called as Meissner effect, in which the magnet could levitate on the superconducting material. Yttrium barium copper oxide, or known as YBa2Cu3O7, is one of the famous superconductor as it has high critical temperature up to 92 Kelvin, in which it is high enough as the liquid nitrogen is sufficient to cool the YBa2Cu3O into its superconducting state. This is the example where the magnet could levitate on the superconducting material. YBa2Cu3O7, also commonly called as Y123, is an isotropic superconductor, and the crystal structure was determined to be in orthorhombic unit cell structure. Based on this unit cell structure, it is in a sandwich form in which the copper plane was in the center, and that's where the superconducting current flows. Next is the problem statement. The growth of the YBa2Cu superconductor has its own magnetic properties and also granular in nature, but its properties of high temperature superconductor is distressed from the weak link of flux spinning, which resulting in the degradation of superconducting properties of the samples. Thus, by the additions of graphene oxide nanoparticle in appropriate amount, it can enhance the critical current density and also the flux spinning. In this project, it has two objectives. First is to synthesize the YBa2Cu superconductor added with 0.0, 0.2, 0.4, 0.6, 0.8 and 1.0 weight percentage of graphene oxide nanoparticle via solid-state method. And the second is to characterize the effect of phase formation and the morphology of YBa2Cu superconductor when added with graphene oxide from 0.0 to 1.0 weight percentage. In recent years, numbers of researchers has become interested in the usage of graphene oxide nanoparticles.
For methodology, the solid-state method was used. It all started with all the raw materials, yttrium oxide, barium carbonate, and copper oxide were weighed and ground for 1 hour. Then, the ground powder was calcined at 900 degrees Celsius for 36 hours. The obtained compound then was undergoing the intermediate grinding for 1 hour before the additions of graphene oxide nanoparticle was added. The blended powder then was pressed at 13 mm and sintered at 900 degrees Celsius for 36 hours. As for the results, the slide shows the X-ray diffraction analysis result. The first graph shows the combinations of graphene oxide nanoparticle and pure YBa2Cu, while the second graph shows the XRD of YBa2Cu added with 0.0, 0.2, 0.4, 0.6, 0.8, and 1.0 weight percentage of graphene oxide nanoparticle. From the second graph, it shows that there is small intensity of X-tropic of graphene oxide nanoparticle in each samples. Table 1 shows the lattice parameters of A, B, and C axis unit cell volume of YBa2Cu superconductor with graphene oxide content. It portrays the variations of lattice parameters results from the internal stress induced by the graphene oxide nanoparticle. However, the orthorhombic structure in all samples is still preserved. The increasing of orthorhombousity is due to the increasing of oxygen content in the reaction mixture of the graphene oxide. Next is the scanning electron microscope analysis. From the SEM micrograph, the enhancements of grain size of YBCO as the additions of graphene oxide nanoparticle increase. The grain also seem to elongate more at one side, forming a rectangular-like structure. At weight percentage of 0.4, the grain tended to accumulate at the grain boundaries on the surface of the samples. As for the conclusion, the yttrium barium copper oxide superconductor has been successfully synthesized via solid-state method with the additions of 0.0, 0.2, 0.4, 0.6, 0.8 and 1.0 weight percentage of graphene oxide nanoparticles. From the XRD analysis, the major phase of Y123 was found in all samples, while the secondary phase of graphene oxide nanoparticle was observed at 0.2, 0.4, 0.6, 0.8 and 1.0 weight percentage. The enhancements of grain size shows that the increasing of the grain growth of the YBCO superconductor as the amount of the graphene oxide nanoparticle increase. This project contributes to the 12th Sustainable Development Goal, which is the responsible consumption and production. These days, numbers of technologies implement the use of superconductor in many ways, including the public transport, like the maglev train. So, that's all from me. I hope it will be useful for you. Thank you for watching till the end.